Hi everybody, we're going to be focusing on finding the domain of a composition in this video. We're going to let f of x equal x squared minus 4x, g of x equals 2 minus the square root of x plus 3, and h of x equals 2x over x plus 1. We're going to use these three functions to find the domain of a few compositions. Let's begin with g composed with f of x. So I went ahead and wrote out the composition. And what we learned in the first video, or the video by Professor Sullivan, is that you want to be able to find the domain of the inside function and see if the range of that inside function behaves in the outside function. Meaning, the domain for the inside function is all real numbers, but the outside function has a square root, and so when we plugged in that inside function, these outputs plus 3, we need to make sure that this all works inside the square root, meaning that this inside has to be greater than or equal to 0. So again, the way that we're going to do this is find the domain of f first, domain of the inside function, and that's all real numbers. So we don't have to worry about any restrictions on the inside function. And now, to play with the domain of the outside function, or the domain of the composition, the g composed with f, what in this case, and this is why it's a little tricky, is that in this case we need to make sure that the range of the inside function works in the domain of the outside function. So that means we need to solve x squared minus 4x plus 3 to be greater than or equal to 0. And so what this is telling us is that if we have a radicand, everything in here has to be 0 or positive for this answer to exist. And so the way that we solve quadratic inequalities is we already have it equal to 0. So we already have one side 0. Now we want to set it equal to 0 to find the roots. And it looks like this factors x minus 3, x minus 1. So then this means x equals 3 or x equals 1. And from here you can do your sign chart. I like to just picture the sketch of the graph. So here's where the curve is going to cross the x-axis. Because it's a parabola that's concave up, facing upward, it's doing something like this. And so that's telling me that -1 and -3 are part of the answers, because this is where the function is going to equal 0. And we're looking to see where's the curve above the x-axis. For what values of x is the curve above the x-axis? So that's everything to the left of 1 and everything greater than 3. So if we write this domain in interval notation, it's going to be -∞ to 1 union 3 to infinity. So again, this tells us, for instance, that if we were to try and find g of 2, it wouldn't work, because g of composed of f of 2 would result in a negative number in the square root. So this is going to be the domain for g composed with f. Alright, so let's look at another problem. Let's look at the composition of h composed of g of x and look for its domain. Again, I found the composition for us, And so if we realize that g of x is the inside function, and now we're plugging that into h, so this will be 2 times 2 minus the square root of x plus 3 divided by x, which is 2 minus square root x plus 3 plus that 1. And so distribute the top and combine like terms on the bottom, and this is what it simplifies to. And again, so when we're doing the domain of a composition, you don't always just want to look at the final result. You're going to want to start with, well, what's the domain of the inside function? So what's the domain for g? And we just need to worry, again, similar to the last problem, with what's just inside the radicand. And so that means we're solving x plus 3 is greater than or equal to 0, or x is greater than or equal to negative 3. So a domain for g is everything greater than or equal to negative 3. We kind of put that to the side now, and we know that for x greater than or equal to negative 3, we now are going to get a whole bunch of different outputs for this. All those outputs are going to be on the top and then now on the bottom. And now it's like, okay, I have a rational function. With rational functions, I have to worry about the denominator. The denominator cannot equal 0. So to find the domain for h of g of x, we need to solve when the denominator, or in this one, solve when the denominator is equal to 0. So we're going to solve 3 minus the square root of x plus 3 equal to 0. And okay, so now we have a radical equation. The way that we want to solve this radical equation is to isolate the radical. So I'll just go ahead and add the square root of x plus 3 to both sides. And now I want to get rid of the radical, so I need to do its inverse operation. So I'll square both sides. And so now I'll end up with 9 equals x plus 3. And then subtract 3 to both sides, and x equals 6. Alright, so what this is telling us is that for our outputs, if we end up with, what it's telling us is that we can't plug in 6 in for x. And so if we visualize this on the number line, we have our negative 3 and 6. And so everything greater than negative 3 works, but excluding 6. So the domain for the composition is going to be negative 3 to, well, not infinity, to 6 open, union, open, 6 to infinity. So what this is telling us that any number between negative 3 and 6, including negative 3, can be plugged in for x, and everything greater than 6 can be plugged in for x. Alright, I think this video is getting pretty long, so I'll go ahead and hit save, and I'll have one more example.